I'm Frank O'Brien, and one of the things that I do here is this lecture series at InfoAge at ISAC, and the idea is I'm what's called a solar system ambassador, as we were saying before. The important thing is that this is the education and public outreach part, public engagement part of NASA. And in a lot of ways, the Solar System Ambassador Program, and there's 900 of us, we're all volunteers, we don't draw a paycheck, I don't get paid for this. Someone's not paying for the lunch I just had. The important thing is we all have a real need to give back to the communities and all the rest. And that's something which I totally believe in. There's about 900 of us. We're all over the country. And especially with the 50th anniversary of Apollo coming up, you can imagine that we're kind of busy with a lot of these kind of presentations. Because in a lot of ways, we're many people's, I think last year we reached out to over 1 million folks. Yeah, we're the face of NASA in a lot of ways. And so because of that, it's important for us to get trained appropriately. And we are, and we have lots of classes we attend. And also, that we're available for you. Again, if there's any kind of community group, a library, anyone that needs to have someone talk on any of the things that NASA does. And over the years I've been doing these lectures, I don't know, I think we've hit on just about everything or something close to it. So, we're coming up to a neat anniversary. Actually, yesterday was a neat anniversary. 58 years ago, yesterday, some crazy president, only been in office about 4 or 5 months, made a great challenge about going to the moon. And this July 20th, we're going to be doing 50 years since that moment. That was arguably the greatest technological feat mankind has ever done. Quite honestly. Certainly the greatest peacetime event. Few months later, that next year, he had a great speech at Rice University. And it was fabulous. It was actually better than the first one, I think. He says, we choose to go to the moon and do all this other stuff, not because it is easy, but because it's hard. And if that's not, again, we can talk all day about American exceptionalism and all the rest, American greatness, but that's exactly the kind of challenge people want to have. This is something that, holy cow. It's a challenge to, in a sense, our egos. Yes, we're trying to beat the Russians. We're doing it for science. We're doing it for all the other things. Only one little problem. We had no idea how to do this. We had no freaking idea. They figure, we'll just call up Boeing or someone and get a contract. Yeah, get me to the moon next month. Couple years, end of the decade. Says, yeah, we'll send our sharpest people on it. What does this look like? This isn't being funny. This isn't crazy. We had, paper studies, but on a practical level, we had no idea of what was needed to go to the moon. We knew it would be like this, right? Come on, just about everything in the 40s and 50s, that's how you went to the moon. Right? Nod your heads. Yeah, that's how you do it. And that's how they started doing it. It was a little bit more sophisticated. It was going to look like this. And right now I'm trying to nail down the contract. This isn't some fantasy art stuff. I'm trying to nail down, I think it's at a museum in San Diego, the actual contract where this was proposed. And it won the contract. It was North American Aviation, which eventually did get the final contract. But yeah, that's how we're going to land on the moon. One big honking rocket at the bottom. Smaller section on top to get you home. All made sense, right? Okay, it doesn't have the sexy lines and the fancy fins and, honestly, that did look pretty sharp, right? Right. That's how we were going to go to the moon. And it's got interesting little things like a little radio dish to get back to Earth. That's how we're going to do it, right? Take a look up at the top. See a small problem, maybe. Guys are laying on their backs. Now, I can't back into a parking spot to save my soul, right? Never been a passion of mine. Okay, fine. Well, you don't have anyone sitting there looking out the windows. And all this fancy autonomous stuff like you'll find with some of the allegedly self-driving cars. None of that existed, of course. There was no computer powerful enough in the entire world that could do even the most basic stuff. And so, it was kind of crazy. Little things sticking out the top, those aren't antennas, those are periscopes. This got worse. So you're laying on your back, thing is 50, 70 feet high. You're looking through a periscope, backing into a parking spot on a place you've never seen before. There could be rocks, craters, et cetera, et cetera, et cetera. How do you fly something like that? How do you, there's 1,000 things wrong with it. Oh, and you got to play with the throttle and all the rest. And oh, did I tell you you've never seen this before? And you only have a little periscope-y kind of view? This was not going to work. Again, what could go wrong? Lots of things. They gave up on this real quick. This was called direct ascent. That was the dominant way we were going to be going to the moon. It was going to require a rocket about the size of a 45-story building, weighed about, not quite as much as a battleship, but something of that magnitude. Understand the biggest rockets we had right around this time, well, the first stage would easily fit in here. And now you got some two-thirds the size of the battleship New Jersey. What could go wrong? Oh, sure, we could do it. No, we can't. And so what they did was that they broke up the mission. One of the dumb things about this, take a look at what you're bringing back. You're going to land in the ocean, so you got parachutes to take you down. You have this really thick heat shield to make it through the atmosphere. You have a ton of stuff that has nothing to do with getting you on the moon. When was the last time you heard someone using a parachute on the moon? It doesn't work. It doesn't work at all. Heat shields? That was a couple tons right there. And in space flight, especially when you're trying to do something like this, weight is everything. Toward the end of the development of a lunar spacecraft, we're going to look at that. They paid thousands of dollars an ounce for every ounce they could get off that spacecraft. They were dipping panels in acid, chemical milling, just to reduce the weight. They had wires so thin that if you bent them the wrong way, they would all break. They would just snap. And yet it had to be strong enough to go through the rigors of launch and all the rest. Weight is everything. And you're telling me you want to bring a ton of heat shield and a half a ton of parachutes down with you, only to bring it all back up again because you're not ready to use it yet? Well, of course, that was nuts. Absolutely nuts. So what we did was that we, after a lot of debate, we talked today about, we'll refuel some freighters in space, all the rest. That's all science fiction. And it will be for a while. That's my opinion, but I think that's true. But, again, you have the question of what do you need to get down to the surface of the moon, just down to the surface, and just what you need to get yourself back up. No parachutes, no this, none of the food you're going to need for the next week or two. You need a very, very basic transportation system. All those fancy legs, do you need to take those back up? No. What good are landing legs going to be once you leave the moon? You're not going to land again. There was a marvelous author absolutely one of my favorites. Antoine de Saint-Exupéry, French author, died in the Second War. You might know one of his books called The Little Prince. And that was like an odd one. Most of it was on aviation and flying philosophy. And he said perfection isn't attained when there's nothing more to add. You have perfection when you have got to the point where there's nothing left to take away. And that's very true. Take away everything you don't need, and you create the vehicle to land on the moon. Everything hyper-optimized. An amazing piece of engineering. The only thing that would come back is what we call the command and service module. That conical shape, that pointed end at the front, that's the only part that came back in. That has the fat heat shield and the big parachutes and the tons of food and all the other goodies. And that never lands on the moon. There's no reason for it to. It sits, waits in orbit with one guy. Two guys go down to the surface. This is the architecture we came up with. And instead of this monster rocket, you'll see it called Nova, the best engineering was just artist concepts. It was so ridiculously huge. Everyone agreed that. You just couldn't do it. But we had the Saturn V, and we have a model of it over here, which was a horrifically large beast, as is. Imagine something twice the size of that. Yeah, being needed. This was just at the feather edge of what American engineering could do. Absolutely one tiny, tiny step ahead or behind the impossible. So, when we're talking about getting rid of weight, this is inside. This is actually an exhibit I put together at a museum out on Long Island. How much does this weigh? 5, 10 pounds, at most. And okay, it's not the most comfortable, but you'll survive for the next hour and all the rest. When you have a seat in a spacecraft, they're a lot more complex. They might actually weigh up to 100 pounds. I got 200 pounds of seats because I have two guys there. You're in 1/6 gravity. Tell me how much you need to sit. Even I only weigh 30 pounds on the moon. So, chairs go out the door. Forget the chairs. Now, so you're going to be standing. Now, when you land, you're not going to be screaming in, slamming in. You do that, bigger things are going to break. And you can go boom, like that. And they actually have, and you can just barely see on the guy's hip, you're actually cabled to the floor. Your feet are Velcroed. Velcro? Oh, yeah. I can show you other pictures, but yeah, there's Velcro patches on your boots, and there's Velcro on the floor. Why do you need a 100-pound chair when a couple strips of Velcro and a couple wires are going to help you? None whatsoever. You'd never, with the way this thing eventually evolved, you'd never be able to fit them in there anyway. It was that tight. And again, you see the mannequin we have set up. The other guy is standing pretty much just a little right of center. You're already bumping elbows. Oh, and you're in your seats, and now you got to get a backpack on and squirrel out through a hatch. What are you going to do with the chairs? But now that you're standing, instead of having like a bubble canopy like they were thinking, like in a helicopter you would imagine, and the windows would weigh a couple 1,000 pounds because you want that great helicopter view. Well, now you're standing up with your face up against a much smaller window. It turns out your field of view is as good, if not better. Thousands and thousands of pounds saved. Right off the top, just by getting rid of chairs. This is the level of smarts that they started doing. Now we talk about 1961, May 25th, our challenge to go to the moon. Turns out we were already well on our way. This is Kennedy and a gentleman by the name of Wernher von Braun, who was, pardon? Kennedy, you've heard of him, president, got shot. Oh, Wernher von Braun. And he was the German engineer Operation Paperclip brought him over. He was the architect of the V2. And we could spend, and we won't, talking about the role of terror weapons now going into civilian space. We won't do that today. But the important thing is, he started his work building these moon rockets, starting with a much smaller version, in 1958. That was 3 years before Kennedy. Whatever. The reason why Kennedy said, let's challenge to go to the moon, was that most of that stuff was already built. This wasn't out of whole cloth. We did not go to the moon in 8 years. It was more like 12, 13. We'll say 12. The monster engines for the Saturn V, that was also a project started in 1958. So by the time Kennedy took office, a couple months, he's asking, what can we do to beat the Russians and all this stuff? Because we were properly humiliated. The Russians had been up for a couple days. Well, they had a one-day mission. We had 15 minutes and 37 seconds. Not exactly encouraging. And we're just sitting there with our nose bloodied and all the rest. Yeah, we did have to beat the Russians. Yes, there were political implications. At the same time, this is a challenge that only America could do. I firmly believe that. We were the only ones that had the resources, the money, to do that. And so he actually visited the site where they were building all these right around the time, within a month or so before he made that grand pronouncement. And he visited him again just 2 or 3 days before his death to watch all the tests going off. And so it seemed like, this was something that was real. It wasn't fancy artist pictures. So, but we didn't know how to do this. Building the rocket was easy in comparison to all the other things we needed to do. Can we put a human in space for a couple weeks? That's what some of the mission designs were looking at. We had 15 minutes and 37 seconds. You could practically hold your breath that long. And a good third of that time was under a parachute, so he's just sitting there filing his nails on the way down. In order to have those two separate spacecraft, that crazy looking one that landed on the moon and that command ship, they have to separate, and then they have to get back together. Can we do that? There's whole branches of mathematics that hadn't been tested in real life. Can we do that? Can we get all the smart people, some sort of reasonably competent computer, this one over here, to do it autonomously, because we have to do this without help from the ground. The big worry was, and again, think of mid-60s Cold War, I can remember this, it was completely reasonable expectations that the Russians would jam all of our communications. So all of this was designed not to be completely controlled from the ground, but to be completely independent from the ground. We had to be able to do that. So now all of a sudden, yes, we have all the support stuff on the ground in Houston and around the world doing tracking and computer work and all the rest. But in a lot of ways, out of necessity, these guys had to be on their own. Sir?
Didn't they also demand that? Not being just passengers, they demanded I watch these network programs. And about
That's grossly simplified but accurate.
You said, no, we're the pilots.
Yes and no. Yes and no. He brings up an excellent point. There's a fabulous cartoon, and it's in one of the books or something that I have. Here's your question. When you're designing all this, that's basically the way the cartoon is. You have two buttons in your spacecraft. One says go to the moon, the other one says go home. And you see these guys reading books, playing cards, all the rest, because they have nothing to do. And that's a great idea. Press one button, off to the moon. Press another button, on your way back. That wasn't anything that was really seriously advocated. Because what happens if something breaks? Say, for example, your oxygen tank blows up on the way to the moon. it can't possibly happen, right? Of course it can, and it did. And so, given the level of sophistication of any kind of spacecraft, aircraft, and all the rest, remember, aircraft companies built these things. There was no spacecraft company. There was a tremendous amount of manual control override. It's grossly oversimplified to say, oh, they want it all automatic. And then again, what happens if something breaks? You know, you can't control the horizontal or vertical. And the reason why there's just walls of switches was an ugly reality of the fact that there was no computer or more sophisticated control. It really was an extremely manual spacecraft. If you look at the cover of my book, that's the panel for the command module. And it's just a wall, switches, dials, meters, that kind of thing. And that wasn't because they wanted to do everything. They needed to be aware of the condition of their spacecraft. If you take a look, like I had my little Cessna, and it had a very, very simple instrument panel. But even with that, my situational awareness of all the important touch points, how high I am, how fast, which way am I going, how's my engine doing, and so on and so on, that was still enough to fill, a panel that big. When you're talking more sophisticated, you look in like cockpits of the older airliners. Walls of switches, dials, and meters. So, again, that was exaggerated. It wouldn't have looked a huge amount different than this. Wouldn't have looked a huge amount different. So, the other last thing. If you're going to the moon, you're just not going to sit there and look out the window, right? Nah, you want to get out. Can we build a mobile, flexible spacecraft? We call it the spacesuit. Had a great talk a couple months ago on spacesuits. It was actually very cool. But think of what a spacesuit is. It's a spacecraft. It has to have your oxygen. It has to clean the air. It has to keep you warm. It has to keep you cold. It has to keep radiation out. It also has to be flexible. You can bet the Apollo spacecraft wasn't too flexible. How do you design something like that? And again, the spacesuit talk, we went into all the evolution. And it actually went back about 50 years of development. Before, the Playtex company, yes, cross your heart, was the one who got the contract because they were masters at making garments that were flexible, well-fitting, and they understood the human body. When you think of it, a bra company comes in and does this, that's crazy. Who else would you get that knows the human body better? True fact. So anyway, we have to learn all this stuff. We sent up astronauts early on, just little spams and cans, but they came back okay. The Gemini program, my God, that was probably the least known, least understood, least appreciated program NASA's ever done, and that was the only reason why we could get to the moon. We learned how to live in space for 2 weeks. It's pretty miserable, but not a big deal. I mean, it's a big deal, but we learned how to link up in space. That was groundbreaking. And they actually tried it a bunch of different ways, refined the techniques to the ones that they used on the moon. And of course, being able to walk in space in a flexible, portable spaceship. Think of that. We all talk about how wonderful the first moon landing was. I'll make an argument that the boldest one was 50 years ago last Christmas. And again, I was 12 years old and I remember it like it was yesterday. We went to the moon. Now with Apollo 13, we know, we had a problem, we had a lifeboat, they had none of that. And this is the very first time they've done it. No backups. Nothing's going to save you. That was the gutsiest move. And also the very first time after the moon rocket had its second flight, it almost destructed. Now we're going to put people on it and go to the moon? That's pretty bold. On a system a spacecraft that's only been tested once? That's pretty bold. When they came up with the idea, they didn't even have the software written. That was pretty bold. I'll argue that was just as gutsy as landing on the moon. So we leave. 50 years ago, July 16. Now, the way we're doing this, we go around the Earth once, check out everything, make certain that everything is okay, because once we fire that engine again to go to the moon, you're on your way and you're got a long way to get back home. So it's lots of checking. Is your guidance system, is all the environmental stuff, is your computer, all that stuff, is it working okay? And then it's good to go to the moon. So we go out, and these paths, again, you're not shooting at the moon. You're shooting where the moon's going to be in 3 days. It'll come up to meet you. At the same time, you have this massive engine. Huge. Not the big ones on the bottom of the Saturn V, but still pretty impressive. It wouldn't fit in here. And in order to get to the moon, they want to be accurate within just a couple miles an hour. Hopefully less than 1 mile an hour error. And they were usually pretty spot on. They were that good at figuring it out. But yeah, sometimes you might have to make a mid-course correction. Oh, we're a little this, let's scoot over this way. It turns out they were very minor. Really minor. Good to do. Yeah.
What is an injection?
Okay, I want to make a transit, I want to, whatever, lunar for the moon. So it's to the moon, and they call it an injection, or they're firing up their engines to start their way on that path. NASA's like that. It could be worse. I could, the acronym is TLI, and if I kept saying that, you'd throw me out of here. But yeah, and so there's a trans-Earth injection when they fire the engine to go home. And you'll see that up there in the upper corner. And again, all of this, and the guidance computer, again, I have plenty of different talks on it, was able to navigate within a couple hundred feet and a fraction of a mile an hour. That's pretty good. Sometimes I get lost going to quick check. But the idea is the two spacecraft are going to be joined up. They go into orbit around the moon. That lunar orbit insertion, lunar orbit insertion, the lunar module separates and starts its descent down, starts firing its engines. The mothership, the command module, stays and orbits the moon. The idea is if there's any problems, if the lunar module can't get back up, the command module is perfectly situated to rescue them. You got to have these kind of, it'd be great if all three guys went to the moon, but honestly, what happens if something breaks and you need help? And so all of this stuff had to be figured out well ahead of time.
The command module can really help them?
Oh, absolutely.
You can land also?
No. If you're on the moon, you can't get off, you're stuck. But if you're in even the most wretched orbit, it can come down and help. I have a whole section on it, chapter 4 in my book. Yeah, and the idea is, depending on whatever, at any time after they separate, the command ship can duplicate all the maneuvers the lunar ship can and recreate all the stuff it has to do, and they'll link up in some horrible, wretched orbit that they'd have to get out of, I'm sure. But the whole idea is always maintain an option to abort and get people back home safely. So, yeah. That's why you have all those switches and dials, so you can do things that don't say more than go to the moon, go home. So anyway, they get into lunar orbit, and if you see that crater, I guess it's under between the word at and the, kind of at the top, right where the shadow starts, that's a little bit right around where the landing site is. You want to land at dawn. And not just because it's starting off of a brand new day, but there's no atmosphere. And if we go out, excuse me, I got a bit of a cold and it's clogging me up. If we go out, we can kind of, even if we're driving in Nebraska and it's all nothing but flat, we kind of have a sense of distance. We kind of have a sense of, oh, that's 3 miles away. You know, in the desert, it's a little bit tougher. In a congested area, you know, with dirty air, you know, things kind of get lost in the smog. Okay, fine. But we have a good sense of that, or at least we're attuned to that. There's no idea of that. So the only cues you have for when you land are shadows. Now, at high noon, how many shadows do you have to work with? None. At dawn, the sun's behind you. And trust me, there's times when you want to just go home, you just want to land someplace else in a plane if you have to land straight into the sun. Princeton Airport is real bad for that. If you land at dusk, the sun is exactly at the end of the runway. You can't see a thing. And your plane goes boom, 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 boom on the way down. So the sun's behind you. You have these nice long shadows. The relief comes alive. And so you want to land early morning. Here, this time of year, it might be like 8:30, 9 o'clock in the morning. Give you an idea. That's their first view. They were going to land the next day. Eagle has wings. Now they're separated. Now the two are on their own. We hear of, oh, well, everyone was all brilliant. Oh, there was a little computer problem. This was almost not to be. Very, very honest. They were too high. They were going too long. They weren't even close to their landing site, and that was the good news. They were very close to an abort because they weren't even going to land anywhere near their landing site already. Computer could adjust if it knew. And they understood after the mission what the problems were, and they fixed them. But, okay, so you're way over the landing area. And then as you're coming down, your computer starts acting up. We'll talk about that in a second. No, I won't talk all day about it because that'd drive you nuts. But because now they're landing in a spot they weren't planning on, it's loaded with craters and boulders and all the rest, and it's like, I can't land in this. I have to get around it. Now, you only have a tiny amount of fuel. You have maybe 60 seconds to make your decision. And that's either go home, land successfully, or crash. Those are your only three. That's the only way that day was going to end up. Successful landing, a successful abort, or 2 dead guys. It's nice to know your options are real clear like that. There's no black and white. And they landed with about 30 seconds of fuel left. Originally, they thought it was about 15 seconds. It turns out it was a little bit more. There's stories on why. But you're out of gas. What are you going to do? You can see your shadow right below you, and you have literally something flashing saying you're practically out of gas. Time to go home. Think of that. The computer problems, and again, I'm not going to go into all this as much. The most computationally intensive part, the one that worked the computer hardest, was the landing. There was a ton of things going on, tons of information it had to present to the crew, a ton of information it had to absorb from all the different radars and accelerometers and all the rest. And they knew this was the most intensive part for the computer in the mission. Now, we've all had times when we've had a buggy website or something, and it just hogs the entire laptop, and you can't do a thing. You know, Weather Underground, wonderful website, great radar, wonderful weather forecasting. It's all part of Weather Channel. Will crush my laptop. I have a reasonably good one. It just takes up all of that. They were aware that this is a very busy time, but now all of a sudden it's like all of a sudden you have someone browsing Weather Underground, and it's soaking up all the computer time in the machine. They didn't know what, but now it can't finish its work. It won't hang up. It won't stop working. But it realized that, oh my God, I can't finish what I've been asked to do. I have no idea why, so I'm going to throw it all away. I have no idea what the problem is. Let's just start over. This is not the same as rebooting. If I reboot my computer, if I rebooted right here, right now, when the computer comes back up, would I be back on the same page on this presentation? No. You're landing on the moon. Your whole life depends on what that computer stores, and now you want to wipe it out and start over? No. Throw away the work. It's like PowerPoint crashing. Windows stays up, and it's actually very good. We can beat up on Microsoft all the time, but it is pretty rugged. So, it starts throwing away work. Threw away everything. Said, okay guys, let's try it again. Now, it's taking its time. You're going further and further beyond. You're paying more attention to the computer issues than you are with where am I going? By the time those things settle out, it's like, oh my God, we're heading toward a big crater. The restarts, these weren't reboots, these restarts as they called them, and they had a little note on someone's desk. The guys in the back room were all aware of this. If this doesn't happen continuously, these are very special problems, very well-defined problems. If these don't happen constantly and are just intermittent, you're go. You can keep going. If it's constant, just gagged up and all the rest, yeah, it's time to go home. But we can tolerate a problem. We can't tolerate a complete failure, but we can tolerate a little bit of a problem. So these restarts were considered okay. We were go for landing, and we did. And yes, mankind will never be the same, blah, blah, blah. This is Buzz coming down the lander. And just like all good men, it's our job. The first act that Neil Armstrong did, after one small step, et cetera, he was given the garbage to throw out. Got to take out the trash. That's garbage you don't need, and well, if you don't need it to go home, well, yeah. So, it is a magical place to be on the moon. And for the first time you see it, I wish I was there. Occasionally my ex wished, but that's another story. No, not really. But again, just a snapshot like this, a nice little panorama, you can learn so much that you didn't know 10 minutes before that picture was taken. Absolutely amazing. And that's the only picture of Neil Armstrong on the moon. He was the one that did all the photography, except for a few times when Buzz took the camera, and there's stories about how badly Buzz handled that, but he was lucky to get one picture of his commander.
So what is that station in the middle between the flag and the...
Oh, this little strip here? That, I was going, you're a great straight person. They didn't have much time, only 2.5 hours, to do all the stuff that they wanted to. They only carried 3 experiments to run. One of them, and we'll take a look at it, one of them was a laser reflector, the other was a seismometer, and this was simply a sheet of extraordinarily pure aluminum foil to capture particles from the sun. They called it the solar wind. The sun does have a wind coming out, and it does disrupt the Earth every once in a while. But yeah, and that, you figure it's simple. It doesn't have too many moving parts. You just unroll it like you would a window shade, and boom, it's working. At the end of the moonwalk, you just zip, roll it up, throw it in the box. Very little muss or fuss. And for the very first time, you're able to collect particles from the sun that they've never had a chance to do before. So anyway, yeah, this is what we saw. This is a lousy picture. It wasn't anywhere near as nice as all of that. I really toy with the idea of having talk about the television and all the rest. There's an acquaintance of mine who worked on the cameras at RCA. And I would almost be terrified for him to show up because he would be able to punch so many holes in it compared to what he knows. It almost wouldn't be worth it. But anyway, so this was the lousy picture we got. This is actually the best you could do with the limited radio capacity, bandwidth, that they could do. They only had a black and white camera. They were lucky to get a good picture like this. And it worked. It really worked. It almost, if you got it in high def IMAX, I don't know if it would be as magical. Well, maybe it would, but anyway, so how do you get these pictures? Now, this is the exhibit over at the Air and Space Museum in Washington. You see that gold foil? It's actually not gold. It's a material called Kapton. Wrapped kind of package hanging off the side. When Neil Armstrong first comes out, he's got a big ring, and he yanks it. And that pulls the pins on this little thing. This is actually all folded up when they're landing. Now it's let go, it plops down. This is where they keep all their equipment that they're going to need for the moonwalk. You didn't see them handing down, here's your shovel, here's your scoop, here's your camera. It's all in there. And it's tough to see in this picture, on the right-hand side, about a third of the way down is the camera. And the camera lens just sticks out a little bit. It's all nicely protected in this insulating wrapper. This is what it looks like with the wrapper pulled away. They've taken out some of the tools, but you see in the center, there's 2 rock boxes. You just pull them out, you open them up, you throw your rocks in there, you seal them back up. All the tools would go on the left and right. And here's one with a little bit more things. You see there's a scoop and some tongs. And also right in the center, upside down, is the camera. And its lens is pointed right toward the ladder. If you ever watch the complete moonwalk, the first pictures are upside down. And it was just a fact of how they had to mount it. And that was the latest, easiest way. So that's where the camera was. Everyone always asks where the camera was. And the other question is, where'd the flag go? The flag actually was one of the last things that they even thought about. It was only a thing that they added about a month before the launch. Nobody even thought about planting a flag. There was conversations, it should be a NASA flag, maybe the United Nations, but those conversations just evaporated and all the rest. So now everything is all packed up, it's already on the launch pad. How are you going to rearrange everything for a big flag? And where do you get a flag to put on the moon anyway? You know where they went? A hardware store. It might have been, does anyone remember Channel Home Centers? I think it was around that era. It might not have been Channel, but they went to Home Depot. And they got the flag there. And so now where do you put it? The only place they could put it was that they bolted a little box onto the side of the ladder. It's the only place it would fit. And so, that's where they put the flag. They just take the cover off because it had to be protected from the engine and all the heat and all the rest. It was all nicely wrapped up. There's actually a whole essay on the people that did this. And having to squeeze inside the rocket and sit there and bolt it on. So,
how long did the flag last?
We'll talk about that. I love the straight people. I mean, they see this stuff. There's like telepathy to look in the computer to see what the next slides are going to be. One of the gents that's not here today, Jules, he's dangerous. I swear to God, he's hacked my computer. He knows the entire thing, and he will just sit there and like pester me. And it's like, Jules, that's the next slide. He does that. So anyway, the other 2 experiments, and you see the flag. You really can't see that solar wind experiment in the background. But what's in front of Buzz right now is a seismometer. Are there moon earthquakes or moonquakes? You learn a lot about the interior of something by listening to how it vibrates. Turns out the moon is very, very different from us. And that lasted a couple months at most. The solar wind experiment, they packed up at the end of the EVA. But the one experiment that you can use today, and people do, is that kind of like white-angled device in the back. And you know how on your car, the lenses on like your backup lights or something are all these like little corners that do a great job of reflecting back? You find them on reflectors on bikes and all the rest. That's all it is. Oh, it's impossibly pure quartz and highly polished and all the rest. But the brilliant thing is, you fire a laser at this, day or night, and it will hit that and bounce off, and you can measure that. You can measure the motions of the moon, and we do. We find out that, and this is the accuracy that they have, the moon is actually moving away from us a couple inches a year. We can measure it that closely. And from that, we can also measure our own plate tectonics, our own drift of the continents, just because we know these things so well. So those were the three experiments. The one, the laser reflector, it turns out it was so important that we put two more on the moon. The Russians put one down. And the really sad fact about the Israeli lander that crashed a month or two ago, NASA's only experiment on it was a reflector. It's that important. So, it's a shame.
Did that transmit back to Earth?
No, it's totally passive. That's the beauty of it. It's just a mirror, or a corner reflector, just like on your bike. Oh yeah, and it transmitted back. It lasted for, I think, 2 months. And experiments that were put on later missions lasted so many years, they actually ran out of money. And I think it was in 1977, they said enough is enough, and they just turned them off. Perfectly working. And they said, we ran out of money. Only cost them a couple million a year to get all that from the moon.
Frank, was it the Apollo 11 where they crashed the lunar lander back into the surface?
They crashed all of them on the surface just to see, since the way you do seismometry is that you could either wait for an earthquake or you can create your own. And okay, you don't really create earthquakes, but what geologists do is that they'll plant a very known amount of explosive and they'll fire it off, and that creates all the vibrations, and that's what they use to figure out. And it's a huge thing in oil exploration. Well, you're not going to get some, what do they call them? The oil rig guys, doesn't matter what. Go there, plant a charge, go back home, just to whatever. But you got this 1 or 2 tons of lunar module that you can't take home. Remember, it doesn't have parachutes or a heat shield. It's not going home. So you might as well have it crash in a known location, kind of nearby. And from that is enough of an impact, just like an explosive charge. And it turned out after this mission, they ended up putting all the rocket stages after they were done shipping them to the moon. The last stage smacked into the moon. They find out the moon rings like a bell. It wasn't like, oh, boom. It just went, totally a shock.
What about the iron content?
No, it has nothing to do with iron. It has more, in fact, it has very little iron as a core, which they find out. What they find is that because the core is so small, the mantle, which is very thick, is the thing that's reverberating. So, all very, very interesting. And if there's any crazies that have an argument about did we land on the moon, for 10 years, we've been photographing it. We have mapped the moon in such brilliant detail. Hey kids, you're late. You're late. Well, I'm a man of a certain age. That makes everyone a kid.
All right.
Come on in. Oh, yes, please. Anyway, real quick, because we are getting late and we're almost done. We have a spacecraft for the last 10 years that's been mapping both the surface height, hills and valleys, as well as all of the, just the photographic things, plus a lot of other science. We bring this spacecraft down. It's called Lunar Reconnaissance Orbiter. We bring it down so low, about 10 miles above the landing site. See those little streaks? One going sideways, another one down. Those are footprints. Footprints. Yeah, we can see footprints on the moon. Oh, you can't see the individual treads, but that's the detail that we can get. Come on in, we're just finishing up my lecture on Apollo 11. Now, that looks kind of like reasonably flat. We all worried about all those rocks and boulders and all the rest. With all of this brilliant data, with all this fantastic data that we're able to get from this spacecraft about how the hills and all the rest, and of course where all the photographic details are, we can create a movie. And we have this, there's a whole set of gorgeous, gorgeous movies all from this. But to give you an idea what the landing site looked like, here you go. And this was actually just done last year. We can zoom in, we see the footprints. See them going down to those experiments and off to the upper left, to the TV camera? Those are footprints. But what did the area look like? You know, we see that. What kind of context do we have? So we put a little pin down, marker. And that's the moon, as they saw on the way in. They were originally heading for that big crater. They had to get out of the way. But you see, there isn't a single smooth surface anywhere. Think of that. And you got to find a place to land in 15 seconds. I can watch this all day. I think I will.
Did you see the Oculus movie?
No, I don't even know it.
Microsoft Oculus, Microsoft Build conference. It's kind of a bad joke, but the Microsoft Oculus, at the keynote of Microsoft Build, a demonstration of the Oculus. The Oculus was a 20-year, a culmination of 20 years of research. They took all of the data from Apollo 11 and they built an Oculus movie. It failed at build, but they said, well, we scrapped it. But they built it and it's on YouTube. It's pretty good.
I'll have to take a look at that. No, I've seen, you see, all this data is completely public. Let's put it this way, you're going to be buying a lot of hard drives for it to hold it all. I mean, it's like terabytes now. But its resolution down to about that much over the entire surface of the moon, which is roughly the size of the continent of Africa. That's a lot of data points. Everything from albedo, you know, what the colors are, to the altitude. I mean, again, when you take a look at how...
Is that the footprints going out?
Those are footprints, yeah. And this isn't the highest resolution ones. From some of the other landing sites, you know, they had the little rover that they drove. You can see the individual tire tracks. And that thing wasn't much wider than this. Individual tire tracks. Man on the moon. If that doesn't blow you away, well, then you're not a person. I mean, that's just dazzling. I got to see it again. But yeah, again, you're approaching from the right to the left. And they had to fly over those craters. But you just look at how this is considered very, very flat, and you see that there's nothing flat about it.
Did Neil Armstrong do most of the final actual landing because it fails?
No, computer never failed. And that's the one thing which, you know, I mentioned in my book and all the rest, is that the computer, if there's any computer, I don't know, a computer background, but today we would call it a hot I/O. You're just getting constant data streaming in that you're not expecting. It was a hardware issue. It wasn't a hardware, nothing failed. It was acting the way they improperly designed it. It was a bad interface design. Anyway, the whole idea was it's throwing away all this work because it's going, I have no idea what's happening. It's just something is taking up all my time. It's like going on some of these websites that'll just soak up your whole laptop, and you're going, all I want to do is find the weather. There's a couple that are, TMZ apparently just hammers your laptop as a good example of a bad website. So it threw away the work. It handled it brilliantly. It threw away the work. It did not reboot. Because I was saying before you guys walked in, if I rebooted this, do you think that when it comes back, I'm going to have the presentation in the same spot? No. But you're landing on the moon. You can't have it throw away everything. Imagine if you're driving a Tesla and the autopilot reboots. Where am I? What's ahead of me? I have no idea. Boom. You can't have that. And so, and again, we could talk all day, and I'll be happy to, about the computer. I make a very strong argument that it's about as powerful as this, 60 years later. And I'll defend that. I really will.
That powerful?
We'll talk those details later because I just want to finish this up. We're just about done. Anyway, we don't have time to see this one more time, and that's upsetting to me, but when I go home tonight. Anyway, so we have the landing site. This is not Apollo 11. But on the last missions, they had the rover park a couple hundred yards behind it with the TV camera on, and you could watch them leave. That is beyond cool. And so, yeah, that's what it looks like. The upper half, all that stuff that you don't want to take with you. Why do you need landing gear if you're not landing anymore? The bottom part's used, as a launch pad, leaving all that hardware that they don't need anymore. Why do you need it? And off you go. So we're just about done. Of course, we didn't just do this once as a stunt. We did it half a dozen more times. One time we didn't make it. Thank God the crew got back. But this actually is a picture of an acquaintance of mine, Dave Scott. And he chose this place really, for lack of a better phrase, because it's a place of grandeur. There was tons of science there. The one place that he had the option of going to was uninspiring. But when you look at some of the hills and the river valley, they call it a rill. It's actually a collapsed lava tube. I mean, that's a heck of a place. Well, billions of years ago, about 3 billion years ago, the entire solar system, we had a great talk. You ought to come to these more often, kids, The solar system evolution, everything was built 4.5 billion years ago, give or take. About 800 million years after that, so we're talking 3.5-ish billion, we had a period of just massive bombardments all through the solar system. It's when the solar system totally rearranged itself. You ought to come to these talks more often. You'll learn all this stuff. And because of that, you have chunks of planets flying everywhere. And all of a sudden, the moon's being hit terribly. The Earth is. Everything is melting. And yeah, I mean, there were liquid planets because it was all molten at the time, or a good chunk of it was. And that happened because we can date the rocks. You take a look at the moon, you see the dark areas, the man in the moon phase, that's where the biggest impacts were. And it hit and it just melted everything for hundreds and hundreds of miles. And it also smoothed things out. These are the places we went to, were these smooth areas that were melted. It's just way too rugged. I mean, could you imagine trying to land a jetliner on a mountain, in a mountainous area? I mean, it's a great way to break up a perfectly good airliner. So, anyway, yeah, places of grandeur.
What about the flag? The flag they keep it.
Well, if you take a look at those pictures, you notice how everything is real close to the... we're done. I mean, okay, Apollo 11, blah, blah, blah. Whoops, sorry. Okay, if you take a look, there's the lunar module in the center, and the experiments, they're maybe about 100 feet away. The flag was probably not more than from here to the wall away. There was a little problem. Not a problem. No, wrong word. when it came time to go home, remember that's a rocket engine, right? And a rocket engine goes, and the films, they had a little movie camera, a little 16 millimeter camera in the window, and you just see the flag going, boom. So, more than likely, Apollo 11, it was just because they weren't allowed to go too far away. The idea that Neil Armstrong went as far as that crater, that was not in the script. First off, they had no idea they'd be landing miles away from where they should have, but he was the commander, he's exercising his privileges, right? So, when this happened, and if you look at the movies of this, it does, it's 3,000 pounds, 3,500 pounds of thrust. It's like a jet engine. And everything goes flying. You can bet after that, they put the flag a lot further away. Now, what happened to it? Again, remember, they just went down to the 1960s equivalent of Home Depot and bought a bunch of flags. Government money at work. They contracted for it to be $1 million a flag. Now you go to Channel or whatever it was, or Home Depot, you pick it up for $5, $10. It was a basic nylon flag. Now, one of the things, if you have a flag here, especially if you go up and down some of the shore houses and all the rest, and it seems like, when my folks had a shore house, we always had a flag out. In 5 years, your basic Mark I Mod 0 Home Depot flag, nylon flag, starts fading. And on the moon, it's about 5, 10 times brighter. It's a white flag now. No, let's not talk about white flags of surrender. But yeah, it's totally bleached white by now, I'm sure. And again, if you go, oh my God, couldn't NASA design anything again? They only decided on carrying a flag a month before the mission. This was not ordained. That's why they had to run to the Home Depot. They had no idea, or there was no thought about permanence and all the rest. I'm sure there'll be someone happy to replace it. Actually, you can't go up and replace it. It's now considered a World Heritage Site, and it is totally off limits to everyone. The first moon landing and the last moon landing, both. Can't come within, I think, 2.5 miles. 2.5 kilometers, sorry. So you can't replace the flag much as you'd like to.
That's good. Then it seems like we've done everything, the moon, we're not going to really use the moon to go to Mars. Why are we going back? Is that just propaganda?
Why did we go the first time? Yeah. How come we can't do it in the last 50 years? And that's not the craziest statement. Why did we need to go there in the first place? Beat the Russians? Again, I'm a man of a certain age. All you guys are far younger, but the important thing is, at the time, that was a big deal. We were freaking humiliated in science and technology. Smackdown, smackdown, smackdown. Yeah, we built the atomic bomb and won the Second War, but the Russians were rolling right past us. At the same time, yeah, just like the very first slide I put up. We're doing this, we're going to the moon, not because it's easy, because it's hard, because this is what, America is good at. Taking a really hard thing to do and making it happen. Yeah, it's going to cost us, tons of money. Flags and footprints, absolutely. The Chinese are already working out there. They already landed on the far side of the moon.
Frank, isn't one of the compelling reasons because there's feelings of reinforcement?
That is one of the great, most bogus arguments, and I just love hearing people talk about it. Okay, helium-3. The sun, the solar wind particles, part of it is an isotope of helium. Helium normally has 2 protons, 2 neutrons. Helium-3 has 2 protons, 1 neutron. What's the big deal about that? It turns out you can use helium-3 to do a very high energy fusion reaction. This is 180 degrees different than a fission reaction like the nuclear power plants we have today. It's actually what powers the core of the sun. And everyone goes, oh, what we can do is strip mine the entire planet or the entire moon so we can get a few hundred tons of helium-3. We put it all in a fusion reactor. The only thing is they don't exist. And have you ever tried to strip mine an entire planet? We're happy to get a couple scoops of this stuff.
The energy it would take to bring it over there and bring it back would be really...
Okay, in fact, the last guy to walk on the moon, Harrison Schmitt, is a huge advocate of this. Now, I live in Princeton, or right by Princeton. We have fusion reactors running right now up the street at what's called the Princeton Plasma Physics Lab. It is Tomorrowland. You know of PPPL?
I was going wear that shirt today.
Oh, is that right? You work there?
Oh, I visited.
Tell me that isn't 20, I mean, that's Star Trek. That is pure Star Trek.
Like the old one, the big one.
Oh, the Tokamak? Yeah.
They were just downsizing.
I think it's the TFTR now, isn't it?
Yeah.
And in France, they're working on, it was supposed to be built by now, it's now got another 10 years, a new reactor, which is, if it works, it's going to be fabulous. It's called ITER, or ITER, depending on how you want to do it. And right now, the fusion work that we do, we're done with the talk, we're just chatting now. And yes, thank you very much. Now, the important thing is, we can do these shots of fusion, and they only last, I think maybe we've gotten a couple seconds. The brilliant thing about nuclear fusion, where you take lots of hydrogen or deuterium and mash it together, is that you get a boggling amount of energy and no radioactive waste. You know what the waste is? Helium, stuff you put in balloons. We are not splitting atoms like we do in nuclear power plants now, which causes all the horrible waste. The only thing is, you're trying to recreate the core of the sun. And it's also the thing that powers the hydrogen bomb. Exact same process. Now, this is the easiest reactions. And what this ITER will do, ITER is, the whole idea is, build a reactor that now will have continuous fusion. And the brilliance behind that is now it's the reactor after it will be a commercial production, fusion, making power, running homes, and all the rest reactor.
Wasn't that the first idea when they started at Princeton in 56 or something?
Yep, and it'll probably always be 20 years away. Because they realize there's one of, you think going to the moon's hard?
They got to one point, 10 years further.
Yeah, and it is. It's perpetually 20 years away. ITER was supposed to be finished by now, and they're still building it. Although it has a huge amount of promise. It really does. And they wouldn't be sinking this much time, money, and effort into it. And again, of course, they're always trying to do this stuff on a shoestring budget. If you put in the money like they did for the Manhattan Project or the moon landing, they'd be done a decade ago. But that's not the case. Budgets are measured in hundreds of millions of dollars, not tens and 20s of billions of dollars that you need. So the helium-3 twist is that this is a different reaction. It's far more difficult. In fact, when you start reading about it, there's nothing good about it, although it does release a tremendous amount of energy. The idea is, where do we get this fancy isotope of helium? Well, we can go to the moon, strip mine the entire surface, again, the size of the continent of Africa, and then we'll be able to make electricity. That sounds kind of ambitious. It turns out, well, how do they know about all? Where do you get helium-3 right now? It turns out you can make it cheap on Earth. I mean, it's not cheap. It's like $1,000 a gram, but that's fine. A gram goes a long way. You can make it on Earth. Why do you need to spend hundreds of trillions of dollars strip mining the entire moon? And then you lose the man in the moon, by the way. So I know everyone loves to talk helium-3. That's when I just turn on my heel and go out, because those are crazy people.
But isn't there a finite amount of helium that's an issue?
Well, when you're talking, especially some of these crazy isotopes, and in helium, this particular isotope is a bit esoteric, you manufacture it. Atomic bombs are all made out, when you look at that piece of metal, that doesn't exist in nature. We had to make it atom by atom to create the plutonium. And you have special reactors whose only job is to take uranium, throw some neutrons at it, let it decay a bit, and then you get this plutonium out of it, and you have to do it atom by atom. To make helium-3, you start with tritium, which you can make, but you breed it out of lithium, I believe, and then you let it decay a bit, and then poof, you have your helium-3. It's a big-ass reactor, it's a mess, but you don't have to, it's tough enough to get to the moon, and now you want to strip mine it? Not likely. We could talk that all day.
One of the other things that we're looking at, Chinese are interested in where we're not helium-3.
Water. Water. Now, they have found, and it's misleading, it's dangerous to say this, they have not found direct evidence of water anywhere on the moon. What they have found is huge piles of hydrogen that could be water or a hydroxide. Hydrogen and oxygen just bound together. And there's lots of hydroxides in chemistry. It is not a frozen lake. However, there are those that believe you could go to the South Pole of the moon, where all this is. And we have more than a ton of evidence. We know it's there. We know something is there. The idea is you go, get the hydroxide or the water out, you split it into oxygen and hydrogen, now you have rocket fuel. The only problem is landing at the South Pole is tough because the only place that stuff exists is where the sun never goes. Imagine doing anything in the darkest, blackest mine you could find 1 million feet underground, and that's as much light as you'll ever see. Imagine setting up a mining camp there. It's daunting. And frankly, in Frank O'Brien's mind, just in my own Frank O'Brien way, it's far easier, cheaper, easier to bring the stuff from Earth than try to set up a mining camp on the moon in one of the most inaccessible places on the moon and then having to ship it halfway around the moon to the people who are going to use it. So, it's daunting.
So why go back to the moon? Because we've done that. Let's go to Mars instead.
The moon is probably, excuse me, I've been fighting this cold. Either that or all the pollen. The moon, okay, how do we know we can land, how do we know we can live on Mars long term? How do we know that? What's it like setting up a small, I'm not going to go as far as saying colony, we're just going to say multiple habitats, maybe a couple dozen people at most. How do we know we can do that? How confident are we in the technology of all the other colonies we built on the moon? Oh wait, we never did that, did we? We have no idea, when I first started that challenge, 58 years ago yesterday, believe we should go to the moon, blah, 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 before this decade is out. We had no friggin' idea how to do that, full stop. We had no idea. We have no idea how to build a sustainable human presence on Mars. We don't know how to do it on the moon.
Okay, so you do the moon first before you do it on Mars?
It's a heck of a lot closer if something goes, downhill. It's pardon?
Less return.
Well, just like the space station, you go, well, what's the space station doing? A large part of what the space station does is use basically humans as guinea pigs. It's a huge amount of medical things. on how the space environment affects humans. And it is horrible. I mean, it's great to go up for a month or two. 6 months is probably, but the guy that stayed up for a year, and the Russian that went up there, and the gal that's doing another year, she just got her mission extended. If you want to read, it's actually a very good book about what it's like up there, by Scott Kelly. It's called Endurance, and it was an endurance exercise. And the first chapter opens up. He's back on Earth. His lead squeeze gorgeous girlfriend is there. He isn't back on Earth for a day, and he's having dinner and drinks and all the rest. And all of a sudden, his whole body starts swelling up. And his whole skin is on fire. It was like that for a better part of a week. And he goes through it step by step. That's what it's like when you come back from long duration in space, and we have to find a way to fix it. One of the key things, and again, I mentioned this in some of the other talks, especially when you're going to Mars, we have to fix these problems first off. The hardest component, we can build rocket engines, we can build spacecraft. The hardest component of all of that is to put a human in there. That's the most fragile part. I mean, it's just these squishy bags of water and meat that's going up there. Now, the important thing is, okay, and women, you should appreciate this because, again, it's probably closer in your mind. A month in space rots out your bones, starts demineralizing them. The calcium goes out of your bones and your bones weaken in 1 month, every month. And they can't stop this at the same amount of every year in a postmenopausal woman. We have to fix that. We have to cure osteoporosis to get to Mars. It's a 3-year mission to Mars. You lose well over a third of your bone. The first words on Mars, and I'm not trying to make this up, I'm not trying to be funny, the first words on Mars are not, the one thing they're terrified of is I've fallen and I can't get up. And this isn't trying to be funny.
Just because of gravity.
Because there is no gravity. The reason why my bones have a certain mass, when I was far younger man, okay, I'm out, I used to run a lot and all the rest, and you can bet the density of my bones was much more than my sedentary self at man of a certain age. Your bones need, your whole cardiovascular system, your whole body is engineered to live in one gravity that we are right now. Just by standing here, I'm putting enough stress on my body, and it doesn't sound like much, but it's enough stress, that the way the human body is, it's going, I have to make certain these bones are strong enough and let's keep rebuilding them, and let's not get rid of all that calcium and all the rest, so that he won't fall down into a helpless rubble pile. And that is what happens, because when you're weightless, or more than likely in very low gravity, as we find on the moon, or we will find on Mars, your body doesn't have to fight this. And it's very conceivable that when you come home, you will be on a stretcher or in a wheelchair for the rest of your life. That's not a great hero's welcome. That's a terrible thing to do to the human body. We have to find a way of curing that. And if indirectly going to Mars finds a cure for osteoporosis, well, I think that's not the worst spin-off. Jimmy Carter just had a spill. God, he's 92 or something? Something crazy like that? At 92, your bones are, sadly, that's an expected thing at that age, to take a spill. And that's just one of the, what do you do about your eyes changing shape? All the guys that come back, all of a sudden, now they need glasses. One guy couldn't even read the instrument panel on the way down. Your eyes get squished because fluid goes up into your brain, into your head. Being in space is like having a nonstop cold because all the fluid's up in your face. And it starts putting pressure on your eyes, and it only happens to men. They just discovered this 2 or 3 years ago. Figure, okay, well, man or a woman of a certain age, they're now hitting 40, okay, reading glasses is kind of expected. But no, only the guys did. Women do not seem to be affected. Why? I don't know. I'm sorry. Yeah. But these are the kind of things that we have to learn. If we're going to go exploring outside of the planet, we need to be able to fix.
What do you know about the,
Absolutely nothing.
they resurrected something that came out in the 60s? Genetically engineered the astronauts
Oh,
to adapt to conditions in space. I saw something recently that there is some type of talk about that.
that's talk in circles I don't talk in.
Maybe the answer is not to send people.
Maybe.
You do all this.
I'm running way late. Oh, okay, because I want to talk about next month. And just hold on for a sec, because this will be fun.
Back to the problem of, question I had, I'm not a computer scientist, but what was the problem with computers? Why, what,
Okay. How deep do you want to go?
this hard? Yeah,
Okay. It was not an improper switch position. It wasn't a procedural thing. It turned out there was a mismatch in a specification. You had two AC power supplies that were flying around, AC1, AC2. It was spec'd that they had to remain synchronized. It was not spec'd that they had to stay in phase. This then corrupted basically what today we would call an analog to digital converter. That it was effectively, again, there's a lot more, but it was basically saying divide by zero, and which you can't do. And this was never supposed to be allowed. Anyway, so it starts sending all this data, which never should have been sent, but except for this flaw. And now it's soaking up all the processing power of the computer. The errors that were happening was, in order to schedule work in your computer, it isn't like you always have like half a dozen programs running. A bunch of programs run, they run for a short while, and they say, okay, I want to run again in 2 seconds. With all of this processing going on, they weren't allowed to, they could not finish. And because they're always saying, schedule me another time 2 seconds from now, or however. Now it's like, I need to schedule work. I'm too busy. Basically, they ran out of memory. Specifically, you had, we call them processor slots on today's computers. They ran out of processor slots. They only had 6, and they wanted a 7th running. It was 2 different errors, process slots for regular work going on. And again, we could talk all day for all the computer types. That, and why I say it's as powerful as this, in 1960 was running 5 to 7 virtual machines. Yeah, those VMs that I worked on for years. Virtual machines? And that was just a small part of all what it could do in 36K. It ran out of process slots for regular work, and it ran out of virtual machines. And that specifically was the error. The solution was throw away the work, not reboot. The data is good. Something must be wrong with the programming. And so you didn't lose where you were, where you're going, that kind of thing. And we can get far deeper than that. real quick. I'm finally, yes, thank you, God. I have been planning this for months. And it's always been one, sometimes my problems, sometimes organizational problems, whatever. What do you think the astronauts have for dinner? Sometimes, yes, and I will. Okay. We're doing a whole installment on dining in space. And, it's okay, so we have all these things, and they're usually a lecture. This time, and I hope it works, I pray to God, we're going to have a tasting buffet. Just like, when you go to ShopRite or Wegmans or something, someone's always there. It's like, going around at a fancy party and you have appetizers. We're going to have a bunch of stuff. It's not like I have a special connection with NASA to get all the food that they were going to throw away. It turns out a lot of it's commercially available from very surprising sources. And so we're going to have main courses. We're going to have, we'll say bread, breakfast, all the drinks you want. You know, again, it's not like a buffet, all you can eat, like shovel on, you know, piles of whatever. But yeah, little tasting kind of things. Any have any idea what that is? Space equivalent of?
Breakfast burrito.
Cheeseburger. And trust me, I had to go through the health department. Everything is going to be sealed. You will be surprised where they get their stuff from. And one thing I can't do, and I was so upset, but I totally get the idea of what the health department says. And in retrospect, it was a great idea, but a bad idea. One of the astronauts, an Italian fighter pilot, this gal, Samantha Cristofiore, she has kind of like a cooking channel. And it's on her space food. And she gets in with this, you know, super duper Italian chef. And she wanted to have turmeric chicken with champignon mushrooms and brown rice and all. And you're saying, don't watch it when you're hungry. I have it on the laptop, and you don't want to watch it when you're hungry. And so they're doing it in a regular kitchen, and the whole idea is that this is what they're packing for when she did her 6 months on the space station, and then she shows you how it's all prepared in space. And I wanted to make it, because I've made it at home, it's good. And, well, they won't let me do any home-cooked foods, so. Anyway. Thank you. That's your price. I will pay your admission if you do not. No. Those things are evil. No astronaut will tolerate it, and they've been known to turn around if they see it anywhere near them.
Do you need help?
Hey, be here next month. They're always at the last Sunday of the month. And we have way too much fun.
People coming early and helping you next month?
Pardon?
Do you need anyone coming early and helping you?
I'm trying to get Lori organized at times is a challenge. But as a matter of fact, I just put in all the paperwork so the township can, it's all prepackaged, but it's the process. I thought, this will be no big deal because, I'm just buying it. Packages won't be open until I walk in here. But that's not the case. So.
You forgot, it's better to ask forgiveness than permission.
No, I won't even joke about that. First, and there's two things that I hold precious. No, I'm not even going to joke. There's two things I hold precious. Yes, InfoAge. We have a great relationship, I believe, with the township. And to sit there and try to weasel deal around a health code thing, you don't screw that up. More importantly, in my own vested self-interest, I am under the exact same rules and regs as the government servant. That's what this whole solar system ambassador thing is. I have to go through ethics things. And if it came out that Frank did an event where he weasel-dealed his way around health code stuff, which is not onerous, it's a pain in the ass, but it's not onerous, they would yank this so quickly it would make your head spin. And I'd probably support them. You can't do that. No, the answer, I don't even joke about it. So, and yeah, it's a hassle, and I had to do paperwork the other day. I survived. And someone's going to write a check for $42 to the township so they can find out that I'm having pudding cups or whatever I'm having. That's life. And I got too many other things in life to be worried about than that. So. This is fun. I want to see the video again. I like that video.
I'll send you the Oculus movie. Apollo 11.
I don't remember that.
Okay, but I send it to you.
Oh, yeah, I think. Yes. But, pardon? You know what's, Where was it last year? Yeah, you want to see some. This is actually my favorite one. It's from the same visualization studio. This is all done at the Goddard Space Flight Center down in right outside the Beltway in Maryland. And this one guy is brilliant at doing this. And this is just imagery, very synthetically assembled, like they didn't have a spacecraft just sitting there, but they've been there for so long. They get every moment of every day, of every whatever, and they can piece it all together. The processing power alone is breathtaking to do this. But the images are just gorgeous. And you can't argue with little Mazursky either.
Didn't you mention PPPL in Princeton, where they're just research and fusion?
Yeah.
Can I take him?
What is a wonderful, brilliant program, it just ended for the summer, because of the summer, it's only a school year thing, is that they have their science on Saturdays. Go to PPPL, Princeton Plasma Physics Laboratory.gov, Department of Energy there. And they have these Saturday programs. It's not every Saturday, but whatever. Science on Saturdays. And I've been to a lot of college lectures that aren't nearly as good as this. And these are high school and middle school kids being taught fusion and all the rest. And the important thing is, if it starts at 1 o'clock, get there at 11. It is always oversubscribed. I mean, and they'll turn people away. The key thing also is if you have a passport, bring it. You have to have good, valid, U.S. citizen ID, since it is Department of Energy. And every time I go there, it's like, God, I could get college credits for this. And this is just their outreach. I love these images.
PPPL.gov?
Yeah, try pppl.gov. I'm sorry, it's a little tough to hear.
When they were taking the initial photos, like first time,
Mm-hmm.
did they have any issues with solar radiation?
Not really. No. No, film is pretty. It wasn't particularly high-speed film. Oh, hey, be good. And send me the email, please. It wasn't particularly fast Ektachrome. It wasn't like 25-speed Kodachrome, but Ektachrome, standard stuff. And not that you could put it in a nuclear reactor for hours, but the radiation in space is not. If you're going to be fogging film, let's just say you're going to be dead. And somehow they seem to have survived that. Radiation is not that horrible. And the big worry is everyone has a stigma. Oh my God, it's radiation. You know where you get the most radiation in your daily life? Well, it's all, it's mostly from the sun, but yeah. But, pardon? No. You know where you get a huge dose of radiation? You ever go flying? Yeah, you go to a website, spaceweather.com, and that shows you your exposure, and it's about 20 times what you get on the ground. And to the point where, not that it gets close. Now, that is 20 times what you get down here, which is still a tremendous number under what OSHA maximum exposure rates and all the rest are. So you get into this thing, yes, it's 20 times, or whatever the number is. If you're an extremely high level, like if you were flying Concorde when it was flying, it's something like 70 times. And you go, oh my God, 70 times the radiation. It turns out these numbers are still so small that professional pilots, obviously, would be the ones most affected, and they don't come anywhere near the OSHA maximum lifetime dose. And those are conservative. So technically, yeah, there's radiation. It is all very much dose related, and more than likely, the best they can see is that it's nonlinear. Most of the hazard models are based on a linear relationship, which means that there's no such thing as a completely safe exposure. But yet here we are. So
It's just because I know modern astronaut photographers have to wear multiple cameras because the radiation can just destroy the camera.
no. Where do you see that? They have, yeah, but the idea is that you will get some damage on individual pixels, and that does happen. But to completely wipe out a camera, I mean, they take a standard, Canon EOS out on spacewalks. Those are pretty rugged, and if reasonably protected, especially for thermal, they're whatever. They do have a large number of cameras, not so much for redundancy, but it just keeps the number of lens changes down. And that does have a big impact. But,
It doesn't destroy them, but losing a handful of pixels on a camera, for whatever essentially such rare photographs that you can't get much.
I'm sorry, I can't hear.
It doesn't actually destroy the camera, but killing the pixels on
Oh, yeah. I mean, you're going to lose pixels. I mean, who was it? Was it Panasonic who made the full-size image sensor? And they are designed, the manufacturing tolerances allow a certain level of bad pixels just out of manufacturing. You'll never get one that's 100% perfect. And they had a problem where it was more than their standard, and they were still shipping them. And they caught a lot of shit for that. The Hubble has tons of pixels burned out, and yet that still works pretty well. When you're talking especially some of these 20, 25 megapixel arrays, you'd be hard pressed, if you lost 1% of them to really notice a huge degradation. The optics are really 99% of that. Once you have a good, clean image, you'd be amazed, especially if you know which pixels are bad, what kind of interpolation, like they do for the Hubble pictures. It's like I know pixel number 1, 2, 3, 4, 5 is dead. Well, let me extrapolate between the adjacent pixels and I can come with a reasonably fixed photo. And it works pretty well.